What if I told you that a flaw in your blood, passed down for generations, could also be a secret weapon? Today, we're talking about thalassemia. It's a genetic disorder literally written into our DNA. And believe me, it has a story that goes back centuries, and we're about to unpack all of it. Okay, so what exactly is thalassemia? Let's break it down. At its very core, it's an inherited disorder, something passed down through families. And it all boils down to a problem with hemoglobin. You know, that super important protein in our red blood cells that carries oxygen all over our bodies. A good way to think about it is like this. The body's blueprint for making that protein has a major flaw. And that flaw, well, that's what leads to a condition called anemia. You know what's really fascinating, though? The name itself, thalassemia. It actually comes from the ancient Greek word thalassa, which means sea. So what on earth does the sea have to do with a blood disorder? Well, the answer to that question takes us right to the heart of its incredible origin story. And yeah, you guessed it, that story begins right there, in the Mediterranean. The condition was first really noticed in people living all around the Mediterranean Sea. We're talking places like Greece, Italy, and Syria. And that is exactly how it got its name. Okay, but here's where the story takes this incredible evolutionary twist. Scientists now believe that the thalassemia gene actually gave people a powerful survival advantage. How? Well, in regions where malaria was just rampant, carrying this specific gene gave you protection against that deadly disease. It's this perfect, almost unbelievable example of a genetic trade-off, right? On one hand, it causes a health issue, but on the other, it helped people fight off something even deadlier. And that explains why it became so common in those areas over thousands of years. So, you might be wondering, how does this one tiny genetic flaw cause such a big problem for the entire body? To really get it, we need to dive into the biology here. Let's imagine your body's hemoglobin production is like a factory, a really complex, important factory. Except this one is working from a seriously faulty blueprint. All right, let's zoom in on that faulty blueprint. You see, normal hemoglobin, think of it as our body's fleet of oxygen delivery trucks, is perfectly built with 2 alpha and 2 beta protein chains. It's stable, it's efficient. But in beta thalassemia, there's a huge shortage of those crucial beta chains, and that makes the final product, the hemoglobin, totally unstable and inefficient. It's like sending out a faulty delivery truck that just can't do its job right. And from there, this one flaw sets off a pretty devastating domino effect. First, those unstable hemoglobin chains start to damage the very red blood cells they're supposed to be helping. Then, the body, being smart, recognizes these cells as damaged and starts destroying them. And the result of all that? A massive shortage of healthy oxygen-carrying red blood cells, which is what we call severe anemia. Now, it's really, really important to understand that thalassemia isn't just one single thing. It actually exists on a huge spectrum. And where a person falls on that spectrum can mean the difference between a condition you'd never even know you have and one that's life-threatening. So let's look at that spectrum. On one end, you've got thalassemia minor. This is often what they call a silent carrier state. Many people have it and don't even have any symptoms. In the middle, there's thalassemia intermedia, which can cause moderate to severe anemia. But then you have the other end of the spectrum, thalassemia major. This is the most severe form, and without treatment, it is absolutely life-threatening, often causing heart failure in early childhood. And when we talk about thalassemia major, the signs show up really early, usually within a child's first couple of years. We're talking severe anemia, just extreme fatigue, and what doctors call a failure to thrive, meaning they just aren't growing properly. Their little bodies are working so incredibly hard to make red blood cells that the bone marrow actually expands, and this can even cause changes to their bone structure. So obviously, this is a very serious condition. How do doctors even figure it out and start to fight back? Well, that brings us to diagnosis and the key treatments that have changed everything. Diagnosing this actually follows a pretty clear path. It usually starts with a simple CBC, a complete blood count, just to see if there's anemia. But the real key test is something called hemoglobin electrophoresis. The easiest way to think of this is like a special sorting machine for your blood. It separates out all the different types of hemoglobin so doctors can spot the abnormal ones. And of course, genetic testing can then come in and pinpoint the exact mutation in the DNA. Okay, so once it's diagnosed, what happens? For someone with thalassemia major, the cornerstone of treatment is lifelong chronic blood transfusions. These transfusions are absolutely critical because they supply the body with the healthy red blood cells it just can't make for itself. This is usually paired with things like folic acid supplements to help the body in its own efforts to produce new blood cells. But here's the thing, these absolutely life-saving transfusions, they come with a really serious catch. And this is the cruel double-edged sword of managing thalassemia. The solution itself creates a whole new and equally dangerous problem. So that leads to a huge question, right? If you're giving a patient healthy blood to save their life, what could possibly be the danger? The answer, in 2 words, is iron overload. You see, every single bag of transfused blood is packed with iron. And here's the kicker. Our bodies don't have a natural way to get rid of extra iron. So with transfusion after transfusion, year after year, that iron just builds and builds up to toxic levels. And this extra iron doesn't just hang around doing nothing. Oh no, it gets deposited in our most vital organs. We're talking about the heart, the liver, the endocrine system. And it causes severe progressive damage. And this is tragic. Heart failure caused by all that iron overload is the #1 cause of death for patients with thalassemia major. So to fight this, patients have to go through a second, equally critical therapy called iron chelation. It involves taking these special drugs, called chelating agents, that basically grab onto the excess iron and help the body finally get rid of it. It is just a relentless, lifelong battle on 2 fronts. But what about the future? Is there any hope beyond just managing this condition day in and day out for an entire lifetime? And the answer is a resounding yes. Science is moving past just managing the symptoms. We are on the verge of a potential cure. And there are 2 really promising paths leading the charge. First, there's the bone marrow transplant. Remember our factory analogy? A transplant is like replacing the entire faulty factory with a brand new one from a healthy donor. Right now, it's the only established cure. But the frontier that has everyone really excited is gene therapy. This is a revolutionary approach. Instead of replacing the factory, it's like sending in a master technician to fix the original, faulty blueprint. It actually corrects a patient's own stem cells so their body can finally start producing healthy hemoglobin all on its own. So the whole story of thalassemia, it all started with a single flaw in our genetic blueprint. But today, right now, we are standing on the edge of being able to literally rewrite that blueprint. And that leaves us with a huge, powerful question for the future, doesn't it? How might our new ability to edit our own DNA, how will that change the future for millions and millions of people living with inherited conditions all over the world?